Okay, hi again, Alex. How you doing, fella?
Yeah, not too bad.
We're back again.
Southeast team.
That's it, Team Southeast. A bit easy to get to work today, though. Now all the snow's gone. Thank the Lord. Yeah. Okay, so we'll press on, and let me just share my other screen with you just here. And
so a good thing for this session is if you do have any application questions. So if you are considering anything, could be why does can you do this with a laser? Then this would be a good session just to ask that throughout.
Yep. So it is live. So that's why I mentioned a little bit earlier. 3 or 4 product groups we hope we'll get through. If we have to answer a lot of questions, then we might only get through the 3, but we'll see. They say never work with animals or children or lasers live answering questions, but here we go. All right, so sample zone, industrial products. We'll jump on to the first slide. Don't worry, everybody, it's not going to be death by PowerPoint because we're going to get into some practical work. Alex is the genius next door that's going to be pushing the buttons and making the Speedy 300 Flex we've got their work. So we've got sort of 3 main product lines here. So we've got the Speedy, the SP large format machines, and speed markers. So if you don't know what they are, we'll flick on the next page and get into a little bit of detail on those. But we basically find all of our machines, all of our equipment in some industrial processing applications. It's a pretty broad market. Okay, so what sets the detail for what you need? Basic parameters are just, can the machine hold the item that you want to mark or cut? How much power do you need to process it efficiently? And how many do you need to make in what space of time? Yeah, these are the normal sorts of industrial or engineering type questions that we get into with people. Yeah, more power is usually equivalent to being able to process faster in our game. And if you've been watching all of our shows, you'll know that we have CO2 lasers for organic materials, and we've got fibers for uncoated metals, so we can process any uncoated metal, precious or non-precious, or even alloys. So the Speedy Flex that we've got next door, which is Alex will be using, that has both laser types in it, and you don't need to change anything physically to be able to use or interchange between those 2. It's pretty slick, isn't it, Alex?
Yeah, I think that's the great thing is, you're not changing anything. We even have optics that will allow you to use both a CO2 and a fiber laser through it. So it's, no real setup change at all.
Yeah. Okay, we'll flick on to the next slide. So there's one of our Speedies. It's our flagship Speedy 400. Pretty much the fastest laser in the world. I'm convinced of that myself, and every time we put it up to test against something else, we come back with that results. That's good. We have these Speedy lasers from 610 mil by 305, or an old money 2 feet by 1 feet, and up to just over a meter by 610 there. They're safety interlocked. There are pass-through modes on the Speedy 400 where it's possible to work with outsized materials, but all of the other cabinet lasers are safety interlocked. And we get up to 120 watts of energy in these machines on the CO2 side of things, and 50 watts on the fiber. And I should mention as well that we do these with a MOPA fiber option as well. So we won't be covering the MOPA today, but the MOPA can cover lots of special results on materials. So for instance, on silver anodized alley, we could have black text, or on black anodized alley, white text. So there we go. All right, so it's our latest machine. Got our latest Optimotion controller, which gives really intelligent path planning and really speeds up the processing. I mean, compared to our original Speedy 400, which was already a record holder in terms of engraving, I'd expect anybody to see about a 20% uplift in their productivity with this new technology. We use a ceramic laser core, a laser tube in these machines, RF lasers. So we have got such immense control over that. We get excellent quality, even processing at super fast speeds. The lasers use servos, so they're stepless motors, meaning that we can produce the smoothest possible curves. In fact, they will follow the spline curve data. no expense spared, Austrian engineering, high quality components, and we protect all these components with what we call impact technology, and that just makes for very reliable machines. And quite often we find these lasers being used in multi-shift or 24/7 operation. Did I miss anything there, Alex?
No, I think that's a nice comprehensive cover.
I've given you a little bit of a rest there after your session earlier. Our SP machine, so we've got one of these, an SP2000 here at Guildford, but the actual SP large format sizes start a little bit smaller than the sort of 3 by 3 meter you see in the picture there. We start at 1254 millimeters by 710. So we've got a whole range of lasers. We've got 5 in that class that are capable of large format, and we can fit them with as low as 80 watts of energy up to 400 watts. Anything above 200 watts is water cooled, and that gives us a nice stable output all the time, doesn't it, Alex?
Yep.
It's just making sure you're still awake.
And I think the other thing to mention as well is they are, predominantly when we're considering large format machines, we really term them as cutters versus engravers. Obviously, every machine can cut and every machine can engrave, but obviously they're geared towards more cutting than engraving.
Yeah, you start to see that these are sort of the staples of our equipment, yeah, of our offering. So high-speed processing, quality output, I mean, proven reliability. I mean, we didn't touch on it last time, but we've got 8 engineers covering the country, a proper tech desk that's manned all of the time. So we've got excellent response and support. And again, these machines are multi-shift operation. I just want to mention there, because there might be someone watching that processes large sheet materials. These lasers, these SP machines are from the 2000 upwards, are ultra convenient to load because they're open on all 4 sides. And where we've installed these machines, that provides a massive productivity boost as well. Just be able to get just be able to load it and unload it without any hassle or drama. Anything to add there, Alex? We've got a few slides, so otherwise
Yeah, it's good.
Thank you very much. These are the Galvos. We call them speed markers. That's our model name for them. And actually, the coverage is from about 70 millimeters square up to 1300 by 450 mil. Anybody that knows any of these, we won't be covering this today. But these lasers have 2 little paddle mirrors in there. They scan ultra quickly, and it's possible to engrave over 700 characters a second with one of these. So they're very much find them on industrial lines and in industrial marking applications. But just to touch on the bottom there, speed, quality, reliable support, 24/7 operation. That's what all of our kit is about. Okay, shall we pop on to the next session? It starts to get a little bit more interesting now, rather than me spouting figures and everything else. So we're going to have a little spotlight on 3 or 4 of our industries that are using these machines here. So architectural models, concept modeling or designing, engineering stroke manufacturing, so marking, and if we get a chance at the end, some plastic processing as well. So going to the first one, the architectural models. Normally people are looking for a large flat work area for this, so it's the speedy lasers that fit it very, very well. I think if you caught the end of the last session, then you'll know that Job Control works with any Windows software, meaning that if you've got a CAD or a desktop publishing package, most of it's CAD in the architectural model line, then you can output directly to the laser, and that's what most customers do, yeah? And we've also got a new software. I'm sure if you're on our mailing list, so you wouldn't have missed it. It's called Ruby, and it's a cloud-based system, and it's compatible with Windows and Mac. So you still have a PC, Windows PC, next to the laser to drive it and control it. But in essence, Ruby has opened up the output to that through Mac packages and Mac software. Yeah, it's pretty exciting, that Ruby, isn't it, Alex?
Yeah, I think definitely as time progresses, we're going to start to see more and more features, and quite quickly I can see, in the next couple of years, I'd imagine everyone's going to be using that as the the main way to drive their systems.
Yeah, I think it's going to become the go-to method. Okay, so let's have a little chat about modelling in the architectural world. So things don't not everything is made initially to the complete form. I mean, this is just a concept model, and I'm going to say it's got nuts and bolts on it because it has got nuts and bolts on it. That's actually holding up the floors of the car park there on the left-hand side. But a laser can very, very quickly cut out these geometries. They can be quickly assembled, and these will serve perfectly for meetings and discussions in the early days of any building application. Now, of course, as well as the concept models, we get these beautiful detailed scale models that are produced as well. I think anybody that's been around lasers for a little while will have seen these sorts of things, that they get very, very detailed and very complex, and some of them get to be quite large scale as well. So we were just going to have a look at a more simple plan here. We're not architects, either of us. So what we've done is taken a rendered 3D image, and we're going to simply map out the areas that we want to cut. So we'll work on this little fascia here. So there we are. We've just drawn it plan view there. And what we're going to do is use some different settings on the laser, all within the same job, to control what happens. So do you want to talk us a little bit through that, Alex?
Yep. So what we're looking at really is just the fact of that you can take a CAD drawing, even a 3D model, and then you can actually export the face of that 3D model. So you can kind of build the whole thing in 3D in your CAD software, and then you can take these individual faces and export them and just adjust the color lines to obviously then start to very quickly build the basis for your model. It's probably actually, although it's maybe something that seems it's very small, some of these models, it's actually obviously a very complex thing. Definitely the skill some of the people have putting this together is really incredible. And it's also one of the most demanding things, so especially when they're starting to print and cut all the small windows and everything, you really need a system that's going to be very precise.
Yeah, I'm just going to ask a quick question here, because Mark's just joined us, but he said the second part of his question, what can we cut metal sheets? The answer to that is that our lasers don't cut metal. We don't have enough energy to do that. But even where we have had a look at it, what we discovered is, well, after you've cut metal, the metal particulate that's left in the machine requires completely cleaning out. Otherwise, when you go to process a bit of wood, it'll stick into it, and on acrylics it would craze it or scratch it. So it's not actually possible. We don't do that. So it's a different sort of manual. Didn't want you to hang about, Mark, in case you had other things to do and were looking at the wrong set of machines. Sorry about that. Sorry, Alex, I interfered with you there.
That's fine. So what we'll do is we'll just quickly come across and we'll start to have a look at actually processing the file. So again, we'll just do the basic setup, which I'm sure you've probably seen a lot if you've been following our setup over the last couple of days. So we'll take the laser head and then just position that roughly where we want the start of the job to happen. And then I'll quickly show you the file. So here we have the file that we're going to use. So we take the file and we simply snap it to the pointer. So for ease of processing and speed, we're going to work on the final part of the actual model itself. So we're going to cut this window out, and then we've got the little plants which will be engraved, and then we're going to do a score for the people just to give some perspective and try to add some scaling, where people are building these models. So from that point, it's very simple. Just need to make sure the door is shut for the safety interlocks. And then we simply just press start, and away the machine will go.
Yep, so you can see it rastering away. Shall we put the machine in the main view, Alex?
Yep. Let's do that. There we go. So here, doing the rastering process, and once it's done that, it will then start to do the scoring, and then finally it will do the cutting.
So even though it's moving around quite rapidly there, you can see some of our components inside the machine there. So the red assembly there is obviously the laser head with a mirror on the top. The black piece that's about halfway down is the lens, and these are on a blade type. So we fix them into a blade, which makes them ever so easy to get out and inspect and clean, so that you're minimizing the downtime all of the time. So, you know, we're into helping our customers make money by putting good design features in the machine that make it easy to look after and keep it nice and healthy as well. So you can see from the axis there, the x-axis, the belt that is moving the head left and right there is actually forming part of the in-pack protection system. And right on the left-hand side, if it'll come back into view in a little minute. Well done, Alex. You missed the camera. I'm impressed with that. I was getting a bit worried then. You're just going to be able to see on the left-hand side of the view there that there's a cover on the left-hand side covering up all of the motion system. Obviously, there's one on the right as well. So we stop the ingress of particulate and to a greater extent gas by using those.
And so the laser just went slightly out of focus there, just to make the beam a nice little bit wider, and then that just means that when we do our score mark, we get a bit more visibility to it. So you just use the Z offset function in our Trotec driver to achieve that.
Yeah, it's nice to show that. Nice to show that.
So I'll just quickly put this into the window, and then we can have a look at the final. So again, very simple, but we've just layered up the material, and then of course we've then added our little bit of engraving and scaling here just to create the model. So hopefully you can see just how kind of the workflow would be for this type of project.
Yeah, no, thanks for that, Alex. I'll just pop the other screen back up so we make a complete sense of that. There we go. Okay, so if you can see these lines that we drew, the red lines here were actually scored lines, so that was going to allow Alex to put together the model really quickly. If any of you are old enough to remember Letraset, it used to take hours to actually get things lined up nicely, but we can actually put the score lines on there to make that happen. So different coloured lines with different settings for different applications there. I'll just stop sharing that for 1 second, get the mouse back, and we'll step on a little bit with the presentation for you. Okay, so thinking about how useful is that to do? It's obviously going to save a lot of time if you can produce these things in-house. That's why most of our customers in this area invest in a machine. And the time taken to do that, I mean, it was less than 5 minutes. We put adhesive backing on these pieces just here, which had to be stuck on afterwards, and that just makes the job a lot faster to do. You can use adhesives to do that, but we didn't want to get in a mess and stick our fingers together. So there we go, 3 minutes of engraving, 6 minutes of cutting. This is for the entire job, probably less than £5 worth of materials there. So it can make sound sense to bring a laser in-house and do these things yourselves. Of course, outside of architectural modeling, we've got model makers who are producing really fantastic, really detailed scale models of all sorts of things, not just aircraft. And people inside the prop business who can produce helicopters, full size, all sorts of things, accurate to the, you know, a tenth of a millimeter to where a nut and bolt is actually on the real thing as well. So a laser really does allow you to craft up to incredible levels of detail.
I think that is definitely one of my favourite applications I've seen is, as you mentioned, people are actually making full scale models and making dashboards and other instruments, and all just to be a few seconds of footage in film.
Yeah, well, in fact, we should also say that a few Speedies have had a few appearances in films as well. So we had a Speedy 300 in Iron Man, and not so long ago we were on the Gadget Show. So yeah, the Speedy's a bit of a star. Are you happy, Alex? We can jump into the industrial sort of sample zone, the product design. Yeah, so I think everybody would agree that well, I know everybody would agree because it's a fact. 3D printing is very, very prevalent in this market. Yeah. The big issue for a lot of people, if they're just at the concept stage, is you can get through an awful lot of plastic, however, over quite a long period of time. So it can take several hours to produce a 3D model on one of these printing machines, and someone's going to obviously pipe up on the screen and tell me that you can do it much faster, but you've really got to spend quite a few hundreds of thousands of pounds to get a really fast production out of them. So we've got quite a few customers in a diverse range of design industries where they are using a laser, one of our lasers, to make 3D forms from sheet materials. And I know that one or two of them have been able to do this. It's so fast, they'll even do it during a meeting. Yeah, so we can take an STL file and we can basically slice it up into sections. So one of the things that Alex is going to show us a minute is how we've gone about from this STL file for the mouse, and we can produce a model that is absolutely perfect for holding and to get the ergonomics sorted out for it. And you could have several different versions produced in just a matter of minutes. Yeah, and then of course, if you want to have more detail, then we could either work with thinner pieces of material, or of course the design's more sorted out and it goes onto the 3D machine there. So there we go. There's a little example of what we're going to do. I won't ruin it for Alex because he can show us this live on the screen. So Alex, once again, fella, I'll pass over to you there.
Okay.
I can't get my mouse back. There it is.
So what we're going to do is we're going to have a quick look at way to do this. There's lots of different bits of software out here. In this example, we're just going to use a bit of software called Fusion 360. And what you'd obviously have your 3D file. So here we have an example of the mouse. And from this, the next thing we need to do is just to set up the size of the actual material itself. So this allows the software to position the cut lines and also determines how many slices of the actual object it's going to take. You then have the ability to adjust the scaling if you wish, which obviously would be useful if obviously, especially if you're doing back-to-back, making several models, and you want to get a rough idea of the sizing as well. So you can see from this, we simply click on here and it creates a layered, so all of the layers for the object to then be cut. As well as that, we then have obviously all of the files here ready to export as PDF and then obviously put straight into the laser itself. So we'll bring the file up onto job control. In this example, we'll just be cutting into some cardboard. And the other nice thing about this setup, as you can see, is the fact that it also puts on the numbers, so which layer it is, and also puts in some score lines, which are going to allow you to very quickly and easily to align this up. So if I just bring the mouse back across and we'll switch to the in-camera machine. And then I'll just bring this up so you can have a look at this while it processes the job itself. And again, working with this, obviously 3D printing obviously definitely has its place, but often lasers can be overlooked for doing this very rapid modeling and testing. This also has some other nice features where you can actually do interlocked slices. So if you're building something that's very big or more of a three-dimensional shape, then you can actually have it. So rather than always stacked, you can have shapes that are interlocked as well. So there's lots of different options out there.
Yeah, thinking about some of the applications I've seen. So people in the footwear business, manufacturing, others manufacturing guards that would go under motorcycle clothing. Yeah, I forget what the proper name for those would be.
I have to say, I think one of the stranger ones that I had that's maybe a bit out of the ordinary was engraving the bottom of ballet shoes to add grip to the soles. So there you go. You can see, obviously the file's already been cut, so it's nice and easy to cut and then make. And then we can simply take these slices and then just stack them on top of each other.
Yeah, Alex is very efficient at this.
And then we have, let's put it like that, we have our stacked slices. So if I put that down like that,
You can see the form of the
start
mouse.
to see we get some form of the actual shape. And again, this is obviously just for the very early concept side of it, and you can obviously put your hand over it to get an idea of how that would feel, whether actually the whole scaling is right or not.
Yeah, when this was first shown to me, I was amazed at how thick those slices can be. But yet, when you put your hand over it, you feel the form of it. Yeah, it doesn't need to be super smooth to get that effect.
Yep. So we'll
Thanks,
now
Alex.
move on to our next topic.
Okay, so back for me with on my screen. Does it boot yours off there? Yes, it does. That's good. Okay, so engineering and manufacturing. Well, this is a very, very broad sector indeed. So the typical sort of applications here might be rating plates or tallies, or lots of different names for them. But of course, we can find them in lots of other uses for lasers. Instrument marking, part marking. So when I say instrument marking, I'm really meaning these sort of day and night type materials, which are designed perhaps to go into cars, and you see them white engraved in the day, and then that will allow at night time the lights come on for the different instrument panels or instrument colors to come through with the LED lights. QR codes, lots of software can generate those these days. And the Speedy is a very accessible machine, so it's quite easy to get parts of weird and wonderful shapes into them. Let's have a little look at another example there. Here's the day and night engraving onto instrument panels. So you can see some sections have gone through to the white underneath, and that will give you the brightest visibility. The warning light cluster here will only, it's engraved less deeply, so it takes the LED light behind it if it comes on. Let's hope it doesn't, to give you the indication. When we mark plastics with the fiber laser, we can get different colors often on the different plastics. Sometimes additives are added to them. Oh, and I forgot to mention that on the 3D modeling, Alex, I think that we get a nice black mark. Do we get a nice black mark on the material for that?
Yeah. So we can use that to then add obviously some of our identification, so we can actually work with the 3D modeling process as well.
Yeah, just to find us another little dovetail in there with that. Quality assurance and traceability, of course, there's a big market for that. Pretty much everything that's in a car has to be type approved, and it has to be marked to say that it has been tested. So these are perhaps real applications for, or most of the applications for, fiber lasers. But we even have some car manufacturers using lasers to cut out detailed veneers and other pieces of dashboards inside, and in the boat market as well.
Yeah, we also have visited customers where we do the same thing, so the automotive sector, so even cutting out interior trims and cloths, and so it really does cover a wide variety of sections and materials.
Yeah, when you actually start to put your mind to it, you start to realize how many things are actually processed with a laser. So a bit like getting on an airplane and seeing all those laser engraved things behind the seats. Would be nice to get on an airplane again, mind you. I'm looking forward to that.
It'd have to take off and land at the same place at the moment.
Yeah, and you have to wait 10 days to let you off. Okay, so what we're going to have a little look at here is one of the most popular applications, so data plates. So the nice thing about the Flex, or a really good feature of it, I should say, would be that we could use the CO2 side of the system to manufacture jigs, and the fiber side to mark onto bare metals, yeah, or onto components. We're going to be marking some anodized alley, and that can be marked very adequately and nicely with CO2 side of things as well. So shall I pass over to you, Alex? You can take us through the next piece.
One thing, just as a thing to think about, is I'll just quickly bring up the jig that I've created. So if you are making a jig, obviously I've just made this see-through so you kind of see what's going on, but you can actually overlap some of the holes here. So this is to allow easy extraction, but what it also means is if you are starting to do this on, you know, a really higher quantity number, you can also make a male jig that once you've taken this out of the laser, you put it onto, and the pins push up through the holes that you've made in the lower side, and it pushes out all of the parts, which means you can then very quickly get those and remove them from the jig. So you can actually have the jig for loading and unloading, and then a separate little jig that you drop this into that then pushes all the parts out and makes the process really fast. So a little tip there for anyone who's working with jigs. And so of course with this, we're just simply going to lay the parts into the recesses, which is going to allow for nice precise alignment of the actual engraving itself.
Yeah, it's a really important point about that jig. Because if you think how many of those type plates we could get inside a Speedy 400, you know, we're talking about hundreds. So to have them in a nice rigid jig, which is not going to drop all of the pieces everywhere as you put it in and take it out, is a good tip.
So we'll just load that up, and I'll just switch the camera back across so that you can see into the machine. A nice thing about working with the anodized aluminium is the fact that you can really engrave very fast with the process, and you always get a white contrasting mark, so it doesn't matter whether you're using black, red, or whatever color base for the anodizing, you will get a nice color from it. So if we have a quick look at the actual setup for this, generally what we will use is we'll use two different lines and colors. So as you've already made the jig on the laser, you already have the outline for it, and then you can obviously just add your black engraving on top. So it means all of the alignment is going to be perfect for the job.
Yeah, and you can see Alex pushed the plate up to the top left-hand side of our rules there inside the machine, so you always know that you're accurately positioning the job. No point in making a jig if you couldn't line it up.
And again, you can see just how fast that's processing for this kind of work.
Yeah, in fact, we actually lose sight of the laser head in the middle of the stroke there. It's moving so quickly. So I think we've got 4G acceleration on the lasers here, so it's really, really accelerating and very, very, very efficient.
And on the new Speedy, so this is actually our slightly older model, and with the latest one that's just coming out, it's been up to 5G as well, I believe.
Speedy by name, speedy by nature.
So you can see we then have all of our tags nicely engraved. You get a lovely white contrast with anodized, so perfect for rating plates and identification plates.
Yeah, no, thanks very much for that, Alex. That's good. And a good tip as well with the jig. I'm sure people are going to find that useful. Right, so we'll move on into our last section. I make it that we've got about 5 minutes left, so I think we've done better than the other day. Here we go. So let's get the screen back. So we thought we'd look at plastics processing as the next section. Obviously, this is one of the areas that we find, you know, the broadest use for lasers. Yeah, so we're very good at processing very thin to very thick plastics, the laser is absolutely the right instrument for that. And I just thought we would just start with an example and have a little think about what was the most sought after products last year. And of course, if we think about it, we started off in the lockdown not having any PPE, and people came up with all sorts of novel solutions to help themselves. I must admit, I didn't have to walk around with a plastic bottle cut in half on my face, but nevertheless, people were forced to take all sorts of types of action. What I would like to say is that we know from our own customer base that so many customers just got into very charitable effort, giving manufacturing and giving PPE to hospitals and all sorts of medical places. So schools and businesses all engaged with this. The universities. It was a massive effort, and I think laser processors. Nobody said a public thank you, but I'm saying it now. I think the effort was absolutely grand. So we're going to have a little look at that, and we've got a design for a face mask. It's actually on our website. It's part of our sample zones, and there are all sorts of variables on this. But the great thing about lasers, they could process these in a matter of seconds or a matter of minutes, depending on the size of the bed and the speed of the machine. And we're going to be working with some a thin plastic material. So what have we got, Alex?
Yep, so we're all loaded up, so that's the file that we're going to be running. And the great thing about working with material like this is that we can run the machine at very nice high speeds and still get some good accuracy from the system as well. So again, another benefit you would actually find if you were looking at this kind of work, so working with thinner material, is with our new Speedy 100 and 300, all of the electronics are now updated to our latest OptiMotion boards, which means you're going to be able to cut even faster. As an example, we're cutting at roughly about 3.5–4% speed on here. I was working with a higher powered one, it was on relatively thick cards, and I was cutting up at around 15–16% speed. So it's able to really follow those contours really quickly. But of course, even our current Speedy 100 and 300 are very fast as well, as you can see.
Yeah, the that OptiMotion, the new OptiMotion controller is a fantastic bit of technology, and we developed it for large format machines because it was absolutely a necessity for us to be able to traverse at fantastically high speeds over those large tables. So we're basically bringing the benefits of the large format systems to the Speedy range as well now.
And so it's just doing the last few little tags here, and then it's obviously quite simple, but obviously it's an effective way of having at least some basic protection of a face mask.
Yeah, and you can see that a lot of there's some dust going down the extraction ports at the back there. This laser doesn't have under table extraction fitted to it, but that's a real boon for anybody that is processing plastics, for anybody doing cutting really. So luckily with this one, I can say I actually do have one that I've already slotted together. I was going to say I was going to be impressed if you did that within the time we've got left.
It's going to be hard to see just due to obviously the fact it is a clear visor by nature, but you have the little headbands and head straps that you can then obviously hook on, and a lower support that allows it to create that curvature and shape. Yeah,
so once again, thank you to all the laser processors that got involved in that in the early days of the pandemic. I'm sure they did save lives, so that's fantastic.